Hi all. So today we will see the problem of binomial distribution again. A man takes a step forward with probability zero point 0.4 and a step backward with probability zero point 0.6. Find the probability that at the end of 11 steps he is one step away from the starting point. So here you can very well see this problem could be solved by the approach of binomial case. Let us define x to be the discrete random variable which follows the binomial distribution for the steps taken by the man. Then you can see x is following binomial distribution with two parameters. One is n, the other one is p. Okay. So here n is the number of trials, p is the probability of success. Now the probability mass function is given as probability of x equal to ncx p power x q power n minus x. X runs from 0, 1 to 3, etc. up to n, and probability of success plus failure equal to 1. Now we know very well the man will take 11 steps, therefore the value of n is substituted as 11 here. So 11 cx p to the power x q to the power 11 minus x, and x runs from 0, 1, 2, etc. up to 11, p plus q equal to 1. So we just made this probability mass function with the number of trials to be 11. P and q should be considered with two cases. Now let us go with case 1. So what is case 1 here? When the man takes 5 steps forward and 6 steps backward. So suppose if you have a case like the man, this is the man who is standing here, who will be taking 5 steps forward and coming back, he will be coming 6 steps. When he does it, then he will be away from the point of his starting position. So this is one case. So you may also tell we could take 6 steps forward and 5 steps backward. That will also give the starting position to be having one difference. But here I consider 5 steps forward and 6 steps backward. So when I do that, what happens? Like I can just go with what is the probability of forward steps here? That is considered to be the success. Suppose if I consider the probability of forward steps to be success, then the probability value is given here, which is zero point 0.4, and the q, which is going to be the backward position, which is 1 minus zero point 0.4, is zero point 0.6. So we got p and q values. When we substitute this in the probability mass function, which is 11c 5, because we consider the forward position as 5 steps, right? So 11c 5 p to the power x, so that is 0.4 to the power 5, q to the power 11 minus x, so zero point 0.6 to the power 11 minus 5. So when you compute this answer, which will be 11c 5 0.4 power 5 zero point 0.6 power 6, that is giving us 0.22072. So you can just see this calculator in the left side, which will be able to solve this problem just by doing it this way. You can see here, which is zero point 0.4 power 5 multiplied with zero point 0.6 power 6. So this answer, which we have got it here, 0.2207. So this is the case where the man is considering the forward direction to be the probability of success. Suppose the other case, if you take, when the man takes steps 5 steps backwards and 6 steps forward, so he considers 5 steps to be the probability of success, and the steps in the forward position, that is probability of failure. So again the case is with 11 steps, but probability of backward steps to be considered success, which is zero point 0.6 here. So now the p value will become zero point 0.6, but the q value will be 1 minus zero point 0.6, which is zero point 0.4. So just the opposite of the one which we have done in case 1. Now we can understand very well this case. Again you can see 11c 5 steps. This 5 meant for the backward direction, that is 5. Okay, so p to the power 5, that means in backward direction the probability value is zero point 0.6 to the power the number of steps he took, that is 5. q to the power the number of steps he has taken, 11 minus 5. So that is he's taking 6 steps, so it's zero point 0.4 power 6. And once you compute this answer, that will be giving us, like you can see, 11 c 5 multiplied by zero point 0.6 power 5 multiplied by zero point 0.4 power 6. So this answer is giving us 0.14714929115. So now these are the two cases which we got, and we got the answers, which is 0.2207 and 0.1471 with 4 decimals. So when you take either of these cases, in probability that will be the sum of the cases. Okay, that means case 1 answer plus case 2 answer, because we took the forward and backward directions to be the success. So we are just adding those probability values that will lead you to the final answer, which is 0.3678. So this is the answer for the question which we have seen here. Okay, so this is quite interesting problem in binomial distribution. Now let us go with this problem again with binomial distribution. Assume that half the population in a locality are vegetarians. If 100 investigators take 10 individuals to see whether they are vegetarians, how many investigators are expected to report 3 or less were vegetarians? So, in this question, you can see half the population is vegetarian. So, there are vegetarian and non vegetarian. In this, half the population is vegetarians. Okay. So that means 50% of the people are vegetarians. That is the meaning of half the population is vegetarian. All right. Now let us define the random variable x to be the binomial random variable for the vegetarian population. So we are taking for vegetarian population, the random variable is defined as x. Okay. Then x follows binomial distribution with n and p, where n is number of trials and p is the success probability. So the total number of investigators here, how many investigators we have? Capital N is 100. If 100 investigators take 10 individuals, so we're taking capital N to be 100. So the number of individuals they are taking to test, those number is nothing but the small n value, which is 10. Okay, so that is the number of trials. So now let us say P to be the probability of success for vegetarians, which is given as half, as I told you, is 50%. The remaining 50% are non-vegetarians, which is denoted by Q. That is 1 minus P, which is 1 over 2. Okay. All right. So now, when you try to compute this probability mass function, you have the general formula NCX P per X Q per N minus X. This you know. But here, the value of N is the number of people who are taken for testing. They are 10 in number. So it is 10 CX. Half is nothing but the vegetarian population, and this half is nothing but the non-vegetarian population. So it is p power x q power n minus, which is 10 minus x, because n runs from 0 till 10, and the probability of success and failure sum is going to be 1. All right. Now the probability of 3 or less were vegetarians, that has to be tested out of 10. All right. So that means there may be 3 vegetarians, or 2, or 1, or no vegetarians. So there may be 3 vegetarians, or 2 vegetarians, or 1 vegetarian, or 0, that means no vegetarians. So when you compute, so you are going to add, because it is a probability, right? So you need to add it. All right. Now when you want to substitute this x value here, like 0 in these places, so where I point all these places you put 0, and all these places you put 1, and all these places you put 2 again for this case, and for 3. So when you compute that, you get 4 terms here. The first term, this quantity is 1, so you get half power 10. The second term, this quantity will be half power 1 into half power 9 is half power 10. And in the third term, again you get half power 2 into half power 8 is half power 10. And in the fourth term, which is half power 3 into half power 7, which is half power 10. So you can take half power 10 in all these terms which are common. So take it out. So when you take that out, you get the first term to be 1. Okay, here the second term is this 10, and the third term is like this is 10 because it is 10c2, so you computed 10 into 9 by 1 into, which is 45, and 10c3 is 120. So when you just add all these terms, you'll get 176 into 1 by 10 to the power 10. So if you want to compute that here, you can see here 1 by 2 to the power, I'm sorry, this is inside the bracket parenthesis, so you can just make it in the parentheses, like, let me clear. So it is 1 over 10 to the power, sorry, I'm sorry, 1 over 2 to the power 10, just multiplied by 176, and that will give you 0.171875. So for 100 investigators, because we took 10 people to be tested, that out of 10, 3 or less than 3 were vegetarians, is just multiply with 100. So the number of percentages, like, you get 171 this into 100, 17.18 approximately. Okay, so this many percentages out of 10, the 3 or less than 3 will be vegetarian. So for 100 investigators, just multiply with 100, that will give you this value, which is 17 vegetarians. So here, this case is nothing but for 100 investigators. So here I am talking about the percentage of people who are vegetarians. Okay, that is 17%. But here there were 17 vegetarians out of 100. Okay, that is a different case. Okay, hope you understand this one. All right. So this is about this binomial distribution problems. Thank you.